Hello, everybody. Welcome back again. So, this is going to be our last session before lunch, and then we will join again for three more post that. So, joining us next is Harishankar Singh. So, he has 15 years of software industry experience. He is an expert in embedded systems and applications. He's worked in a lot of fields. So, he's worked in storage, telecom, media. He's done AI, speech recognition, and machine learning. So, that covers basically every single domain you can think of. He has been an independent consultant and a trainer for C++ since April of 2020. Other than programming, his interests include being an avid reader, and he loves to travel to far-flung places. So joining us now is Harishankar Singh. All right, there you are. Hi, Harishankar.
Hi, Anu. So thanks. First of all, happy Independence Day to everyone. So yeah, I should share my screen, right? Yeah. So once again, thanks for having me here. So today we are going to talk about. This session is about. This talk is about C++ 20 ranges. This is one of the big four. Out of those four big features, this is one of the big thing where we are going to talk about how it changes the way we look at or the way we write our code, how we can write more modern C++ code when we deal with STL containers and ranges, right? So how it becomes more intuitive and more modern C++ when you revisit your code what you have written and what all this C++ 20 ranges provide us. So let's go through it. So yeah, so first of all, what this talk is all about. So let me just put forward few points. So in this talk, I'm not going to talk about the details, how ranges and how this library or internals is being implemented. And so we are going to we will be more focusing on how it changes the way we code, used to code now, how it changes, what it brings us, and how it enables our thinking, right? And how it makes our code more intuitive and more modern. So this is what we are going to focus on. And second, whatever examples we are going to see here, and I don't claim those examples are the best solution, or there is no other solution could be. So those examples are basically to show how our existing how we used to write code, now how it changes with the ranges. Yeah, so all the code, whatever examples we are going to see here, all those are, compiles well, works fine. So once you can play around with that code after the talk, and you can see by yourself, by yourself. Yeah. So what all in C++20 ranges comes in when we talk about ranges, right? So this is how we have these things into the C++20 ranges. Basically, C++20 ranges is a library. You can consider it like STL 2.0, but it has got a lot of things into it, right? So we have ranges algorithms, right? All algorithms those currently supported in STL, so those are overloaded for range library as well. And we have views. Basically, we will see all those things. So this is something like how currently today the C++20 ranges looks like. So we have a header here, which consists, this is the new header for ranges and views. So in the namespace stud, we have namespace ranges. Basically, this is the namespace which consists all the range algorithms and views. Then we have another namespace ranges views, which basically has all the views and basically all range adapters. And then we have this namespace views. Basically, this is to shortcut access to this is to access your adapters the short way or shortcut to adapters. Yeah. So what ranges are basically? So we have till now, I mean, before C++20, we used to we used to work with containers, right? So basically, containers are, I mean, ranges are basically, the collection of elements, basically, or you can say a range is a group of items that you can iterate over, like the way you used to iterate for STL containers. So it provides a begin iterator and a sentinel. So basically, sentinel is nothing but which basically marks the end of the range. So obviously, I mean, when we say collection of elements or group of elements which we can iterate, so so all the containers currently we have into STL, like arrays, vectors, list, map, all these are ranges. String views, span are ranges, right? So basically the collection of elements which we can iterate over. Yeah. So now what are range algorithms, and what are the advantage, I mean, having ranges and having those algorithms overloaded into the range library? So you can see until C++20, right? So we used to write. I mean, we used to iterate our containers using iterators, right? Now that somehow was not kind of intuitive, right? So for example, until C++20, you can see if we have a vector, right? So if I want to sort this vector, then I have to write, I mean, or I have to provide the begin iterator and the and iterator, right? So I feel, I mean, if we want to sort a vector, I think the vector itself, the name of the vector should be sufficient. So now C++20 onwards, this this code will look like something like this. So we have this ranges. The algorithm, basically our standard algorithm, is now overloaded with ranges. So we can simply give our vector name, and it becomes it looks more intuitive, right? I mean, I need not to think or take care of, I mean, what kind of iterator I have to pass and things like that. I mean, simply I want to sort a range, or I want to sort a vector, I can simply pass on to the algorithm, and it will just give me a sorted output, right? So this is one of the advantage, one of the simplest thing I see, where it becomes more intuitive now. The problem with the previous approach was, like, I mean, for example, if you have passed or your iterator got mismatched, right? So you will see lot of, hundreds of lines of cryptic error messages, right? So you have to be a little bit careful where you have to pass the same iterator, same type of iterator and things like that. But here it becomes more intuitive. You can simply pass your name of the range and you can sort it. So now ranges supports functional pattern. So now we have more modern way of, like you have seen function way of programming in more like almost all the modern languages, right? So now this is something which I see as a kind of radical in C++, where now ranges supports functional way of programming. For example, look at this example. You have this vector, and now I simply wanted to uh, I mean the drop first 5 element, and then what I want to reverse that vector. So now if you see this pipe symbol, which is which is supported in C++20 now with ranges, this allows us to, compose, function composition, right? So simply if you read from left to right, so it becomes like something like I have a vector. From that, I simply want to drop 5 elements, and then I am simply reversing it. So if you read it right, it gives more of a kind of functional way of thinking, right? It's a normal English sentence. I mean, if you write it, that makes it more I would say intuitive and more simple, right? So this is simple. I mean, like function composition. Now we have views, right? So basically, views are something, you have some ranges, and you have some range, and on that you want to apply some operations, right? So you want to apply some operations, and and then you want to see your ranges in a way, or after performing some operations. So basically views are also ranges, and they are like kind of, they supports lazy evaluation. So we will see what lazy evaluation means. And a view is something that you apply on ranges and perform some operations. So I mean, how you want to see, I mean, for example, into your ranges, like in the last slide we have seen that we want to drop first five element, and then we want to reverse it, right? So those are the operations which you can perform on your ranges, and you can see how the final output would look like, right? So the major and the most important thing here is, I mean, when you want to create a view, I mean, basically when you apply some operation and you want to create a view, those views does not own data, and its time complexity for copy, moving, and assigning to views are like constant. So they are cheap, they are not, expensive, there is no copy, so they are like linear complexity. So as I said, views support lazy evaluation. So in our STL algorithms currently, they are like evenly evaluated, right? I mean, the moment you write code, the moment you write or use any algorithm, the result, that code is being executed immediately, right? So now with the views, the current now the view supports lazy evaluation. What lazy evaluation means, you can see here I have a vector, and basically I have a range, and out of that vector I want to drop five elements. So this statement, right, where I am trying to create a view out of the range, this will not be executed until you will not access the view. So basically this will remain in the code as it is, but the moment you will start accessing the view, at that point of time it will be evaluated. So basically uh, this becomes a advantage, and I see it's another one of the major feature with uh, ranges, because now it can be evaluated easily, right? So this is one of the very important feature which I say. So now here you can see in the my view, this is basically a view where I am creating it. When I create a view, it neither changes the my vector. So basically, I mean, those views are whatever views I am creating, it does not impact my original range. And my view basically does not store any element. The time it takes to construct views and its size into the memory is totally independent of the vector. So there is no, I mean, extra kind of, thing that, I mean, there is no dependency between the original range which I was using and the final view which I'm going to construct out of that range. Yeah. So now I will move on to some of the examples, I mean, which I have revisited, which I have seen before C++20 ranges, and those looks to me, I mean, those were earlier, I mean, kind of sounds very complicated. So let me take you through these examples. So there is a very efficient method you might have heard about. I mean, the Sieve of Eratosthenes. He proposed a method of finding a prime numbers, right? So what method he proposed? That you can have a matrix of, or basically you can have a matrix from 1 to 100, and if you want to find prime numbers, so he suggested some statements, and just I mean, those statements are like kind of, if you simply follow those statements, you will see how simply and how easily it can it produces the output which you want, basically all the prime numbers between 1 to 100. So the first statement, it says in this whole process, that first is not a prime number since it is only factor is 1, so we can remove 1. Then the second step, it says the first prime number and only even prime number is 2. So if we remove all the even numbers except 2, then whatever remains, right? I mean, so it basically removes all the 49 numbers, basically all the even numbers. Then same process we can follow. We can remove all the factors of 3, basically, and then it removes all the factors of 3, and then we will have only these many numbers. And if we follow this process continuously for some number of times, then basically, I mean, after we apply this for like for example 5 or 6 or 7, then we will have all the numbers, all the prime numbers between 1 to 100. So all these steps basically, if you read simply like a statement, right? And I'll just think of a I'll pause for a second, and I ask you, like, just think, if I ask you to write into a C++ or any other language, how would you write? It sounds like, it looks like very complicated, right? The moment if I found, right, you immediately start thinking like loops, and I mean traversing those loops, or basically all those things comes to your mind using iterators and things like that, right? But if I take you through the same thing, reading all those statements, and taking the advantage of ranges, right, how it will look like. So let's see. So let's first prepare our range. So here you can see I have created a vector, and I just created this using this std iota, this function. Basically I'm filling this vector with 1 to 100. And then what was our first statement? If we remember, the first statement says that one is not a prime number. So since it is only factor is one, so we simply want to remove one. So how it will look like? So you can see that we removed out from the grid. And in code, how it will look like? So simply I have my range, basically vector, and from that I simply have uh, I have some range adapter, basically views.filter, in which I can simply write a lambda which says, if just written, if n is not equal to 1. So it will just filter out. So basically first statement is simply filtering out 1 from this whole range, right? And now let's go and see how, when we apply the second thing, right? If you want to remove 2, and if you want to remove all the factors except 2 and all the even numbers, basically. So how it will look like? So simply, I mean, if I apply something on this view, on this range, whatever view I remained after removing 1, and if I simply apply another view here, or where I will simply compose another function where I will again filter all those number except 2, those are even numbers. So our output or our final view will look like this in this step, right? So same way we can follow for the next statement, right? So if you want to remove all the numbers 3, so you can see that whole matrix would look like this, and the simple statement would be this. And if we follow same way, so you can see that finally we will have our output here. And this is how our overall way of finding the prime numbers for this particular method. So what things changes here? So if you see, we don't have any kind of looping and things like that. So I need not to think in that terms, where I used to see, okay, what I have to do, if I have to I have to traverse through whole list, or I have to provide iterators, and then I have to apply some filter and things like that. It's simple. Like, if you read from left to right, it becomes a simple combination or compositions of simple statements, right? It looks like you are simply reading a story, right? I mean, I have number, I have range between 1 to 100. I want to remove 1. Then I want to remove all the even numbers except 2. Then whatever output I will get, whatever view I will get, I want to remove all the numbers from all the numbers except 3, and all those factors which I want to remove. So it becomes more intuitive, and the way you think, right? Simply, I mean, if you have a clearly defined statements, and you simply can apply using you can simply implement using those, and converting those thoughts and those statements into the you know equivalent, or you can mimic all those things very intuitively in using ranges, right? So this was our first example. Now the second example is something like, suppose you have a range where what you want to find all the subsequences between pair of zeros, where the sum of those subsequences is an even number. Now, again, I would say take a second and read about this statement. So I'm sure most of you will immediately start thinking, okay, I will have a vector, then what I have to do, I have to write some lambda functions, and then I will start traversing and see that, okay, which number and all those things, passes those lambda, and then, I mean, lot of things, basically traversing it, iteration and all those things will go into your mind, right? But look at this problem from the range perspective. For example, how we can, mimic this simplest way of writing this into a functional way using ranges. So I have this range, so you can clearly see that, I mean, I have, I have to find all the sub ranges where between pair of zeros where the sum of those some ranges comes as an even number. So if somehow, I mean, I think it something like, we have a sufficient information that whatever we want to have, those comes between, I mean, pair of zeros. So basically, we can think it is a kind of delimiter, right? So if I simply uh, break this whole range, or basically if simply put, I can create separate ranges based on this delimiter or based on this delimiter, right? So how it will look like? So this is how it will look like, right? So I have got splitted my range based on all the based on the delimiter. So basically zero is a delimiter here. And then what I want to see, I want to compute the sum for all those sub ranges, and then I want to check for which the sum is even, and that is basically I wanted to find out. So this is how it will converge into the simple sentences, if you think, rather than thinking in terms of iterators and that conventional way of thinking, writing those codes. So how it will look now, and how we can how it will we can see, and how it will look like with ranges. So let's see. So now here, first we have ranges. So let's prepare our range. So this is our range and this is our delimiter. The second step, what we wanted is that if we can simply, break these or split these ranges. So we have like this lazy split view. So basically, this is again a range adapter. So it will create a view. So it will take your source, basically a range, and it will have a delimiter, and it will give you all these sub ranges based on delimited by the delimiter which you provided. Now the second step was to construct our views where we want to accumulate, or we want to see the sum, and based on that we wanted to filter out, or we want to create it as a final output, right? So how it will look like? So this is how it will simply look like. So now I have got views of views, basically. So here you can see these are the views of views. So now you can see, because we had a zero here, so based on this delimiter, it creates an empty view. So what we want, I mean, from all these views, whatever subranges, these are the views. So from all those views, we wanted to filter out the views which is basically empty, or based on the size. So if our if all the views passes this filter where the size is zero, so all those views would be, or basically empty views would be filtered out. And then we want to take only those views for which the sum would be even, right? So this is how, I mean, the whole sequence where we it was like, it was looking like a complicated way of implementing. It becomes very simple, and then and then finally we just printing the view. Those are consist only those views where the even where the sum is for that subrange is even, right? So if we look at those filters functions, right, how it will look like. So basically you can see that here we have an even sum filter where we are simply calling another view, and based on that we are checking whether it is it provides the view which we have is having the sum of is basically even or not. And this is how it will look like. So for example, whatever view we passed, we converted it to a common range. So whatever we passed, and if now the unfortunately with C++ 20 ranges, not all algorithms are supported where you can simply pass only range. So one of them is std accumulate. So that is the reason we need to convert our view into a range. So you can see that simply I had a view and I just called that common. It gives me a range, and then I pass this into a camelid. So this gives me the sum of the view, whatever I had. And then finally here you can see again the view which I had, and I pass it to a range adapter. It gives me whether this view was empty or not. And finally I am printing this. So you can see that again, I mean, when we started with this, I mean, this looks more of a puzzle kind of thing, right? So how with ranges this becomes more intuitive, and it enables us to think more in a functional way rather than more into those uh, programming constructs. So you need not to take a lot of programming constructs where, okay, I have this algorithm, I have to pass iterators, I have to, go each values and things like that. All these things you need not to think. You have to simply, perceive it like, in a functional way. Okay, I have a range, I want to create some sub range out of this, and that operation I want to perform. So simply you can see there is, so till now you can see, I mean, how it becomes more and more simple. And I feel it's more expressive, because reading out like, if someone reads out, he can clearly make out what exactly we are trying to achieve here, rather than scratching the head and looking, okay, I mean, this is the loop and things like that, what this complex logic looks like. So I need not to bother about all those things, right? So this is one of the interesting things. And you might have seen one more thing here, that till now we have not even used any kind of like a loop and things like that, right? So you can simply construct, and you can simply construct I mean your views based on your requirement from the ranges what you have. Now, when we are talking about ranges, it will not be, good if we don't touch a few of these string related problems. So what I mean, so there are a lot of issues, and there are a lot of problems you might have seen with strings, or like those sounds like puzzles, right? So for example, I have a string here, and it has got at front and rear, it has got byte spaces. Now, if you want to simply remove all these white spaces, and finally you want to print your string, or you want to have your output like this. Now, just again, I would ask, I mean, for a second, think about it, how you have to, till now, before C++20, or I would say how you used to write this and how you used to think about it. So I'm sure, I mean, again, this used to trigger, I mean, at least for me, I mean, the moment when we used to talk about algorithms, when we used to talk about these ranges, or basically containers or strings, the first thing which used to come to my mind always those algorithms, right? I mean, and with those algorithms, again, iterators, and how it will, we will loop and things like that. So now, if I want to solve, I mean, when I revisited this problem, this code after C++20 ranges, so how I could see, like, I mean, what kind of pattern I can draw, which I can mimic it, or mimic, or with ranges, I mean, C++20 ranges. So first and very simple thing which I saw here is, what if somehow I can first simply remove all the, all the leading white spaces, right? So if I remove all the leading white spaces, so this is how my string would become, right? Now, for example, now what else I can do? If somehow I can remove leading, the white spaces which comes, which is at the, at end of the string. I mean, basically, second part of the string, right? So now imagine, I mean, if you want to do that, how you will do. So what basically you will do, okay, you want to traverse the list, or basically again with the iterator, you will traverse this whole string, and then you will see, okay, I mean, first non-byte space character comes, then from there you want to take that iterator, and last byte space. That probably would be the way, or simply thinking that, okay, you will go and find that particular place from where first five space, first byte space character comes, and from that point you will get iterator, and you want to remove all those white spaces consecutively, right? But I thought, I mean, it can become I mean, more simple, right? So somehow, if I have this string now, and if I reverse it, right, and apply the second method, second step again, then how it will look like? This will look like this. And simply for this, if I reverse the string again, I will get the output, right? Now you might think, okay, doing these many steps, doing these many steps might be, uh, can create a problem and things like that. But again, think from the range perspective how it will look like, and if we use ranges, and if you create these out of those ranges, if you create those views are, again, I mean, the major point which I mentioned, those views are basically, they don't own data, right? So basically, if you want to get this and you perform all these intermediate steps, right, whatever we are doing, so you can do all those things with very cheap cost, right? So how it will look like if you want to see this? Yeah. So first we are like simple. We have our string view, and we have created our range. So as I said, string views are also range. So what we want, the first is that simple. I mean, what I'm trying to see, I mean, just read the statement and see how intuitively, how simply we can express those statements into the code using ranges, and like these things makes ranges very special, I would say. So what I want, remove all the white spaces till till we find first non-white space character. So if you look at all the range adapters, basically what all kind of views are available. So there is drop while method, which basically creates a view. So it drops all the characters or all whatever you are asking. So it creates a view out of that range, and whatever character you are passing, at the moment it finds a character which is non-white space, a non white space character, it simply removes all those things and give you a view after that, right? So I mean, I had a range here, basically string view that input, and from that I dropped all the characters uh, till the first non-white space character, right? Now the second statement, we want to reverse a view. So there is a simple another view is available. So basically whatever now you have, you want to reverse it, so it will reverse, and it will bring all the white space character now a different, right? So now as we just I showed you, right? Now what we want, after reversing all the characters at front, so I simply want to remove again. So I will follow the same step what I did into the previous first step. So again, a simple statement, whatever view I got after applying the reversing the view, I dropped again. So finally I got the reverse string, and then I got again reverse view, and finally if I print it, then it becomes hello C++20, right? I mean, what we wanted to achieve. So now this is what the thing which I wanted to tell you, that now it provides more modern way of writing the complex or the way you used to write your code earlier, when you used to think about when you used to write code using containers and your iterators and all those things, right? So it becomes simply, I mean, like transforming your English statements to and to like your C++ code, right? And believe me, I mean, in fact, in some of the places when I have seen these examples with different modern languages, I mean, like Python and all, some of them, I found in C++ it becomes more simple actually, and more expressive. So here, as I said, I mean, all doing all those things, there is no extra cost. This view, whatever views we are creating, those views are, I mean, not owning their data. So everything, whatever we are doing, there's absolutely in the linear, time, or basically constant time. And yeah, so uh, this is how, I mean, I feel it becomes more intuitive, and we know that, I mean, what exactly those views are created, and we not to worry about the internal implementation details and things like that, right? Yeah. So now I had another example when I started looking out like how it will look like. I mean, when we talk about again ranges. So I mean, if I don't discuss that example, I think uh, because that examples always I always used to find a kind of very difficult and it was really, I mean, complicated. I mean, I used to feel like, why not C++ have something which makes it simply very simple. So when I started looking for out, we have a string and you want to find all the rotations of the string. Now you just think about it. So when I went back and check again, or I was looking for this how it will look with ranges. So basically, I could not find with I mean something which currently C++ 20 ranges have, but thanks to Marco Arena, I mean I have seen his blog. So there is a library that range v3 library basically. I mean, so whatever currently ranges we have, right? All those things in the range library in C++ 20 base, I mean, basically has, I mean, taken from the range v3. So range v3 is now has got some more views, right? I mean, some more intuitive way of providing those views and things like that, which I mean, you can simply mimic this complicated, kind of algorithm very simple way. So so for example, if I have this problem, so how I used to solve this problem, how I used to see this problem, like I have an string, and if I want to find all the and all the basically rotations of this string, so how we can simply find it. So we can simply very simply, I mean, if we see this, so how I look at it, this problem. So if I have any string and if I add basically, if I add the same string without the last character, so it becomes basically, ABC plus AB, like it becomes ABC AB, right? And after that, whatever the range, whatever the length of the string you have, right? If you apply that sliding, right? And if you traverse, you start creating or you start having that sliding window effect, right? So for example, if I start from the beginning, so I have this ABC, the length was 3, so only 3 character. Then again BCA, and then finally CAB. So you can see, I mean, if I can have this sliding window effect somehow, or sliding window algorithm implemented somehow, then I can achieve whatever I am, thinking. But now implementing sliding window algorithm, again, I mean, you need to think a lot. I mean, you need to consider all those things and those complex way of thinking. So when I was looking for it, so what I found in the range v3, they have something very interesting. So I mean, if you look at this problem, so every rotation basically here is substring of the original string, right? And then the number of rotation is equal to the length of the string. This is very simple, right? So if I try to look at from the range perspective, again, how this complex problem or basically a programming puzzle will look like. And this really, I mean, I was kind of uh, stunned, and I was surprised. I mean, how all these things which I discussed with you uh, finally converge into a simplest way of, I mean, very simple way of doing it. Converts, I mean, converting your simple statement into a, you know, C++ code. So, for example, if I can create, right, for example, there, as I said, in the range v3 library, let's set up and create a simple cyclic view, right? So I have created, so this is basically a range v3 code. So if you want to compile, I mean, you might have heard about the compiler explorer, right? So it's very well support this range v3 library. You can just simply select it and you can compile all the code which currently, I mean, you want to see. And I hope that all these views which I am talking about, particularly for this example, would be part of C++23, and it really makes life very simple and very easy. If you look at now this example, and there are a lot of those range adapters probably we will see in future in C++, and that makes C++ or basically with ranges, it makes life very, very simple. So if you see, we have here what we are doing. So I have a string, and I just simply took the length of the string and I created a cyclic view. So this view, you can see that in my previous slides, this was views, but because currently in the range v3 library, I mean, I think, I don't know the reason probably, but currently this is defined as a view, probably because it is not part of the standard or something. I'm not sure why it is view, but it should be views. And I think in future it will be views when it will be part of the standard. So you can see that what we are trying to do, we have this input string ABC, and we want to create a view out of this string. Basically, that is a cyclic view. So what is a cyclic view? So basically, this will return me a view where all these character of the string would be repeated cyclically. So for example, I have ABC, so ABC, 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 right? So now I have a view with which if, this whole string is being repeated, cyclically. Now what I want, this second step, if you see, we want to create sliding view, right? So now I have a simple, uh, range adapter, basically with which we can create a sliding view, and it looks simply like this. So if I say view sliding and I provide my length, right, length of the string, so it will just create, it will give you all the views, basically implementing that complex sliding window algorithm where you'll start traversing from, you will have ABC, and then you will slide from after one character, and then you will have BCA, and then CAB, like that, and you will have this kind of view now. And then finally what we wanted, so whatever, I mean, as you have seen in the previous slide, that number of rotation would be equivalent to the length of the string. So see, so whatever number of views we have, out of those views, what we want to simply have a first three views. So if we just take those views, so finally I will have a view where I will have only those rotations for the provided string. So after that, if we want to print, we can print all the rotations like simply the way we want to print, right? So so look at this example, and now just recall your earlier way of writing this rotations of a string, and look at this now. So if I read these statements, and if I have ranges and views with me, I can simply express my statements, or express my way, what actually I want to do in a simple way. And if you read it, it becomes more intuitive. I mean, you need, I mean, someone need not to explain to you, right? I mean, view cycle, what it will do. I mean, if you just a view cycle, it gives me a cyclic view, and I want to now have all those views after applying sliding, right? And then I want to have a view, first three views from all those things. So that way I see and I look at it from the range perspective. So yes, I mean, as I said, I mean, you can compile all this code, and obviously the one very important point I wanted to focus, you can see that all those places, all these examples where we were dealing with the containers, right? We are not using any kind of power loop or something like that. So you can see, without you, we are not simply using for loops. What we are doing is we are simply taking the advantage of functional composition and ranges and views, and that too at the very minimal cost, right? So again, I wanted to emphasize, right? I mean, you can see that are views are basically kind of constant in time, lazy evaluation. So with having all those things, I would I would like to say that, I mean, from now onwards, you can keep on thinking, or you can, at least uh, enable, I mean, or you can, go back and see, I mean, how you used to code earlier, and now how C++20 makes your life easier with dealing with the containers and uh, right, I mean, dealing with containers and all those complex problems without being actually complicated, making more intuitive and more simple. So yeah, so having said that, thanks everyone. And now I can go for questions. I mean, if anyone has any question.
All right. Thank you for the great talk. It was very insightful. So what we do next is take questions and answers from the Q&A chat box that we have going on. So the first question we're going to take is from Anubhav. He asks, on slide 15, if you have to deduct the complexity for such an algorithm, how would you approach it?
So slide 15.
Yes, slide 15. Also, to everybody putting the questions in chat, we'd like if you'd put it in the question and answer box instead, so we could have people upvoting it and it gets
Yeah.
answered quicker.
So slide 15, what was the complexity of the algorithm, right?
Right,
So
right.
so as I said here, what we are doing, we are just simply creating views, right? So those views, if you see, I mean, finally, you those views are whatever views we are creating out of array, right? I mean, out of our range. Those views are created in constant time, right? So so basically you are creating views. Those views are they don't own data, right? So you can look at it from that perspective. It is very cheap, right, as compared to the conventional algorithm where they were kind of eager, right? And I mean, they used to where you used to provide your iterators and things like that, right? So here we are simply creating views out of ranges rather than directly using those containers or traversing those containers basically.
All right. So the next question we're going to take is from Hiten. The question is, what is the performance overhead of using ranges? So I'll club this with another question that I saw
Yeah.
earlier, which was, how does ranges compare to iterators?
So as I said, right, I mean, when I talk about ranges, right? So ranges, what ranges are. I mean, so if we want to go, for example, I mean, as I said, ranges, when you talk about ranges, so basically all the containers, ranges provides, the way where we don't want to use iterator. So ranges comes with your begin of iterator and the sentinel, right? So when it comes to sentinel, now you don't have end of the iterator. So now I mean, if you look at from the internal implementation point of view, so this sentinel is basically a kind of information which the kind of extra information which you are providing, uh, uh, and based on this kind of information, compiler can do some kind of optimization with your ranges, right? So I mean, those are the internal details probably. I mean, how compiler use those extra information with the ranges, which finally you can look from that perspective.
All right, great answer. So hopefully that answers your questions. Does using ranges not promote multiple passes over the input, leading to a performance impact?
No, no, here, as I said, right? I mean, so basically, again, I mean, when we create views, right? So here, first we had a range, right? So again, when we were creating a view, right? So what exactly we want to achieve? So with those views, right? I mean, you are not copying and things like that, right? So at least it is cheap from that perspective. So when we are going, I mean, when obviously internally it might be iterating through the ranges when you are creating views, but you are compensating it with those things. And the major important thing, I mean, I'm not sure how internally like exactly it is being optimized, or the way it is being implemented inside views, and I'm sure, I mean, they might have taken care of that internally.
Great. Also, to answer everyone's question about the slides, all presentation talks, the slide deck will be available on cppindia.co.in. So you can go to the website and look them up after the session is done. Okay, next question. Would the sliding view take more memory than we require for actual problem solving? How do restrict memory requirement with ranges?
Again, I mean, this is as I said, this is not a currently part of the C++ standard. Okay, so here again, I would look at it from the more simplicity, simple way or intuitive modern way of implementing it, right? So currently it is not part of the standard, so we probably may want to look into how the sliding view is being mainly implemented in terms of memory. So again, the basic principle which I see is when you are creating a sliding view, right? So it doesn't copy anything, right? So it doesn't own any data. That is the basic principle behind the views. So again, I mean, this is a question of, whether we want to, when we want to check, I mean, in the ranges V3, how it is being implemented. But I am sure that must have been taken care and need to, I mean, look into it. I mean, basically.
Great. The next question we have is from Rahul Jain. He asks, what all constructs does ranges work with? Big loaded question here.
Constructs in the sense, mainly, I mean, if I understood the question correctly, the question is what all containers it works, basically, right?
Essentially, I think they're
Yeah,
referring to constructs from the C++20 standard.
so basically, I mean, the ranges is to deal with, as I said in earlier, right? I mean, as I said in my beginning of the presentation, ranges you can consider as STL 2.0, right? So when I say 2.0, in the sense, I mean, what all we have into a existing STL library, like all the containers. So for example, let's say, if you talk about all the containers, right? So we have a lot of containers like map, list, and all those things. So basically, all those containers, ranges works. I mean, ranges support all those containers. But you had some other, like container adapters, like stack and all those things. So if you see the way they iterates, I know. So the range says that, I mean, you have to have a way of iteration, right? So it is being defined, like what all ways you can iterate. So basically, if you look at stack, queues, and those kind of containers, they don't have, like kind of begin and end iterator, right? So I mean, those are not basically, I mean, considered as ranges. So basically, what is the range where you can iterate from beginning to end? So all those containers are basically supported with ranges. And
Yeah.
and to add to more, that, I mean, whatever those containers, I mean, for those containers, whatever algorithms currently, supported by those containers. So we have algorithm header, right? So that complete header, most of the algorithms in that header is being supported by the ranges, but a lot more has to be done. For example, numeric algorithms, I mean, basically all the algorithms which is available into numeric header and other places, those are yet to be supported. So I see them, coming, into the C++20.
Okay. So I think we'll just take one quick question and then we will be done. So the last question we're going to take is, how does coming up with the sequence of operations to be used using ranges compare against implementing the algorithm using conventional iteration? What has been your experience, for example, with the sliding window thing?
So, I mean, can you please repeat the question? I mean, I
Sure.
lost in between.
How does coming up with the sequence of operations to be used using ranges compare against implementing the algorithm using conventional iteration? So you're comparing conventional iteration versus just using ranges.
No, I mean, my experience, I would say, I mean, it is something like, I mean, whenever I used to look at these kind of problems, right? So my mind always used to go into that traditional way where I used to take care more of, the way I would iterate, the way I will loop, the way I will, store all those, kind of things, which makes, somehow, I mean, not a kind of modern way of doing it, right? So when I look at the ranges for those kind of problems, when we want to deal with containers, I mean, you can compare with any modern language like Python and all, right? I mean, if you want to compare. So now here you have, as in the previous talk, right, where John was talking about, right? You have the abstraction and you have a freedom, and you know that, I mean, how you want to go at low level and how at that level it performs, right? That kind of freedom you don't have with Python, if I am correct, right? But here with ranges, I need not to worry about those things, right? Because I know that, I mean, all those things, when I talk about performance and things like those things are already being taken care. And what I have to do simply is, I mean, I have to form my problem statement more into a, simple way, the way I would like to, explain to someone else, rather than more from the programming construct point of view, right? Where if I want to explain someone, okay, this is the range, so I want to use this algorithm. So what I have to do, I have to take the begin iterator, I have to apply, some operations onto it. All those things I need not to, even think about, right? What I have to think, I mean, how I would like to see my final range. I mean, for example, how simply I want, if I want to filter, right? So if before C++20, tell me, I mean, let's take an example. If before C++20, I would ask, right, okay, I want to, simply filter out all those numbers from a range where you have all the odd numbers, right? So what you will think? Tell me. The first thing will come to your mind, okay, I will have some function or basically maybe lambda, and then you have to pass whole range or basically container executing for all that element, right? And then you have to take care whether I have the default, for example, which comparison, whatever, all those things you have to think, right? But here it is not like that, right? You simply need to think, okay, I want to filter out, call that filter, passing that lambda. So
Great.
I
Okay.
found it more, I found more intuitive and more simple and more expressive with ranges.